Hello students. In today's expert class session, we're going to start the chapter Amines or compounds containing nitrogen. Students, आज के इस lecture में we are going to study in detail the nomenclature of amines, the basic structure, hybridization of amines, the different isomerism which are shown by amines, and then we'll do all the preparations of amines in detail according with the mechanism, including the mechanism. So let's start, students. Before starting the lecture, I request all the students who are watching to please subscribe to the channel. Please like and share this expert session with all your friends. Now, students, what exactly are amines? Now, students, amines are compounds which are derived from ammonia. When you replace one hydrogen in ammonia with an alkyl group or an aryl group, you get an ammonia, you get an alkyl amine or an aryl amine. Specifically, when you replace one hydrogen, you get what is called as a primary amine. Now, when you replace two hydrogens, you get a secondary amine. And when you replace three hydrogens, you get a tertiary amine. Now, student, it not necessarily be that all the replacement have to be alkyl group. Aryl group भी हो सकता है या mix भी हो सकता है. In case both alkyl and aryl groups are attached, then such amines, students, are also called as mixed amines. Amines ka students, we can also write a general formula. The general formula for amines can be written as CnH2n plus 3 and your nitrogen. This can also be written as the general formula for amines. Now students, let's continue with basic nomenclature of amines. Just like students, amines are divided into primary, secondary and tertiary amines. उनकी nomenclature भी slightly different है. Now let's start with first primary amines. Now the basic nomenclature, students, for primary amines is you count the number of carbons in the chain. आप corresponding alkane लिखिए, but E की जगह पे आपको add करना है amine. For example, यहाँ पे there are 3 carbons, so the nomenclature will be propanamine. यहाँ पे अगर आप देख सकते हैं तो हमें ब्रांचिंग है, सो हम नंबर करेंगे हमारी कार्बन चेन को. I can see that the amine or the primary amine NH2 is on the second carbon, so the nomenclature here will be 2-butanamine or butan 2-amine. Both are primary amines. Now students, what about secondary amines? How do we write the nomenclature for secondary amines? हमारे पास दो alkyl group है. Both the alkyl groups can be similar in size or both the alkyl groups can be different. तो आप पहले छोटे alkyl group को हम देखेंगे and we will write the nomenclature as N, the smaller alkyl group first. N-alkyl alkanamine. I repeat, this group will be your smaller alkyl group और ये होगा आपका bigger alkyl group का root. So let's take an example over here. Nitrogen पे यहाँ पे हमारे पास दो alkyl groups हैं. One is smaller group, the other one is bigger group. I will look at the smaller group. The smaller group N पे जो attach है वो methyl है. So I'll write the nomenclature as N-methyl. The bigger group has 2 carbons, ethanamine. Had both the groups been similar, तो n अल्काइल अमाइन हो जाता है. जैसे लेट्स से अगर दोनों ग्रुप होती इथाइल तो n इथाइल इथेनमाइन. लेट्स स्टार्ट विद टर्शियरी अमाइंस. सेम स्टूडेंट्स यहाँ पे हमारे पास 3 डिफरेंट ग्रुप्स अटैच्ड है. आई विल लुक एट द स्मॉलर ग्रुप्स. ये इथाइल है, ये मिथाइल है और ये प्रोपाइल है. द स्मॉलेस्ट ग्रुप इज मिथाइल एंड देन इथाइल. तो अल्फाबेटिकली इथाइल कम्स फर्स्ट, सो n इथाइल, n methyl, and the biggest group had 3 carbons, so propionamine. I hope students you got the nomenclature. How do you write the nomenclature for primary amines, secondary amine, tertiary amines? For any questions or queries, you can always leave your comments behind. Next, let's write the nomenclature for few aromatic amines. Aromatic amines, the first and the most important aromatic amine that you have here, which is C6H5NH2. Students, the common name यहाँ पे थोड़ा important है, आपको इनके common name याद रखने चाहिए. This compound का common name is aniline. You can also call it as phenylamine, but aniline is the most frequently used name. आप phenylamine बुला सकते हैं, आप aminobenzene बोल सकते हैं, but students please remember aniline. Then this you can call this as 2-methyl aniline or orthomethyl aniline. But the students, the name that you should remember over here is orthotoluidine. Okay, remember orthotoluidine. यहाँ पे भी you can remember the nomenclature for this, the common name nomenclature, orthophenylene amine. Now, some more nomenclatures that we have here, people. इसे हम बोल सकते हैं N-methyl aniline. Aniline के derivatives हैं, so N-methyl aniline. यहाँ पे we can call this compound as N-phenyl aniline. And I want you students to give me the name of this particular aniline in the comment section. Thank you so much. I hope everyone has understood कैसे nomenclature लिखना है for some of the aromatic amines. Now next students, we need to study hybridization and geometry of aniline. Now I hope everyone knows chemical bonding. अगर आपको chemical bonding में students you've not done hybridization and valence electron pair repulsion theory, I request you all to please watch the video on hybridization. Ammonia has sp3 hybridization and the shape for ammonia is pyramidal or trigonal pyramidal with the bond angle around 107 degrees. However, students, when we start comparing the hybridization, the bond angle between primary, secondary and tertiary amines, see hybridization to sp3 ही रहता है. But what happens is the moment you introduce an alkyl group, students lone pair bond pair repulsion तो present है, but what happens is the moment you introduce an alkyl group में भी steric hindrance होता है. So if there are bulky alkyl groups present, the bond angle gets impacted, affected, because the bulky alkyl groups के बीच में there is steric hindrance. You can say there is repulsion between the bulky alkyl groups, and hence students, if we observe the bond angle, hybridization remaining the same, what we observe is ammonia bond angle 107 degrees. एक alkyl group, when we introduce that one alkyl group, the bond angle slightly increases from 107 degrees to 108 degrees. The moment you go to a secondary amine में दो alkyl group, bond angle goes from somewhere 108 degrees to 110 degrees. And when you introduce one more, a tertiary alkyl, tertiary amine, where there are 3 alkyl groups, the bond angle becomes somewhere around 110 to 112 degrees. Now, JEE Advanced students, आपके लिए a very very important point that you should remember is when we consider triphenylamine or N, diphenylalaniline. Nomenclature का आंसर भी दे दिया है मैंने. N, N diphenylalaniline, आप उसको triphenylamine बोलिए. What happens in this is the lone pairs which are present on nitrogen, they constantly delocalize. उनको वो resonance में they will move in the ring, they will resonate in the ring. Now what happens because of that, the geometry becomes almost planar. You can say that sp2 hybridization हो जाती है, and as a result of that the bond angle becomes somewhere around 120 degrees. So this point JEE Advanced students definitely आपको याद रखना है. Now let's move ahead with which are the different types of isomerism which are shown by amines. So the first basic type of isomerism is chain isomerism. What we observe here is यहाँ पे I have C4H11N. So I can have straight chain. आप इसे बोल सकते हैं जैसे N-butyl amine or butanamine, straight chain. But what happens here is molecular formula remaining the same, chain the principal chain branch हो गई, इसे हम बोल सकते हैं 2-methyl propanamine. So you students observe here straight chain branch हो गई, chain isomerism. Next we have position isomerism. As the name suggests, the position of the functional group differs. So यहाँ पे what is the position of the functional group? On the first carbon, so butanamine, and over here students, the position of the functional group is on the second carbon, so we call this as butan 2-amine. I hope students everyone got this chain isomerism and position isomerism. Let's move ahead with the next isomerism which is shown by amines. We have metamerism. Let's first understand students what do you mean by metamerism. Metamerism is when we have functional group, molecular formula, functional group all remaining the same, different alkyl groups are attached to the functional group. So here we have secondary amine, but on the left hand side आप बोल सकते हैं कि methyl group is attached. On the right hand side हम बोल सकते हैं the propyl alkyl group is attached. But keeping molecular formula same, what we observe here is on both the sides ethyl group is attached. And hence these are metamers. And next we have people functional isomerism. What are functional isomers? Functional isomers, when molecular formula remain the same, the functional group differs. So if I consider an amine such as C3H9N, I can have the same molecular formula but primary amine, same molecular formula but secondary amine, same molecular formula but tertiary amine. So I can have primary amine, secondary amine, tertiary amine having the same molecular formula. These are called as functional isomerism. This is very important. Now, slightly more in depth जाते हैं हम, especially this is important for JEE Advanced. Chirality in amines और optical isomerism. Now students, majority अगर हम हमारे NCERT scope में देखें तो it is optical isomerism with reference to carbon, but nitrogen can also show if there are 4 different groups attached to nitrogen. तो अगर आप एक quaternary ammonium salt, if we consider a quaternary ammonium salt. What exactly is a quaternary ammonium salt? 4 alkyl groups attached to nitrogen, we get a quaternary ammonium ion. Quaternary ammonium salt. Consider if 4 different alkyl groups are attached to nitrogen. अगर 4 अलग-अलग alkyl group attached हैं, then we say that कि ये nitrogen chiral है. So quaternary ammonium salts are chiral. At the same time, students, in tertiary amines, there's a very important topic जिसे हम बोलते हैं amine inversion. आप नाइट्रोजन इन्वर्जन भी बोल सकते हैं, अमाइन इन्वर्जन भी बोल सकते हैं. You can also call it as flipping. Now let's understand what does that mean. So if I have three different alkyl groups attached to nitrogen, तो हमारे पास tertiary amine है. What happens is there is constant flipping. आप देख सकते हैं बोर्ड पे, there is constant flipping and you cannot isolate. So even though वो nitrogen chiral लगता है, racemic mixture है, but you cannot isolate them out in form of two different R configuration, S configuration. Isolation नहीं कर सकते हम वहाँ पे. Such a concept or such is called as amine inversion. You're not going students that in depth, but एक amine inversion, amine flipping, nitrogen inversion, ये topic for JEE Advanced students को पता होना चाहिए. चलो, now this was nomenclature and for isomerism. We now move ahead with preparations. Let's start with preparations of amines. Now students, the first method of preparation that we have is called as ammonolysis. Hofmann's ammonolysis. Ammonolysis बोल सकते हैं, ये reaction of ammonia with alkyl halides. Let's understand students, what exactly is reaction of ammonia with alkyl halides. A very important reaction and also present in the chapter haloalkanes and haloarenes. Let's start. Now, if I have an alkyl halide along with that alcoholic ammonia. Now students, the mechanism of the reaction is nucleophilic substitution. This is a nucleophilic substitution reaction. I hope students have learned SN1 and SN2, nucleophilic substitution reaction. Now what happens over here is students, अगर हम ध्यान से करें, we get RNH2, हमें मिलता है primary amine and hydrogen halide. Now, students, there are multiple conditions in this reaction. Now, what happens, students, here is, in case if I have excess of ammonia. So, first condition हम देखते हैं, अगर हमारे पास ammonia is in excess है, then the reaction will stop at primary amines. तो reaction यहीं पे रुक जाएगी. I repeat, or you can say the major product will be primary amine. Reaction stops at primary amine. Major product आपको सबसे ज़्यादा product primary amine ही मिलेगा. But students, look at condition number 2. What if we have excess of alkyl halide? अगर वो haloalkane excess में है तो क्या होता है? Students, the reaction doesn't stop at the primary stage. So first step तो यही होता है. The first step remaining the same. What happens, students, in the next step is, ये जगह बना लेते हैं, the primary amine, ये जो आपका primary amine था students, this further reacts with the alkyl halide. ये आपका alkyl halide है. And from primary amine, we now go to secondary amine. ये मिल गया हमें secondary amine. But it won't stop here. Secondary amine again reacts with more alkyl halide, because students, alkyl halide is in excess, so this further reacts and we get tertiary amine. And students, even after forming tertiary amines, it's not that the reaction stops. The tertiary amine, जो tertiary amine बना है student, it will further react with alkyl halide and हमें मिलता है quaternary ammonium salt. और quaternary ये आपका है quaternary ammonium salt. Nomenclature आप इसका लिख सकते हैं students, tetra alkyl ammonium halide. I repeat, you can also call it as tetra alkyl ammonium halide. So students, you have to remember two conditions. If in case if ammonia is in excess, reaction will stop at primary amines. But if the alkyl halide is in excess, it keeps on going and eventually it ends at tertiary alkyl ammonium halide. Now, एक और condition students हमें याद रखना है. If tertiary alkyl halide is used with alcoholic ammonia, then अगर tertiary alkyl halide is used with alcoholic ammonia, then instead of substitution, elimination takes place. I repeat, instead of substitution, students, elimination reaction will take place. So for example, let us consider that we have tertiary butyl bromide. I repeat, we have tertiary alkyl halide, which is tertiary butyl bromide. And over here, students, if we have alcoholic ammonia, then I repeat, instead of substitution, the reaction which takes place is elimination. And we get an alkene. So, आपका product होगा students 2-methyl propene. Yeah, you can also call this compound as isobutylene. You can further say this can form NH4Br. And students, if you want to just quickly understand कि ऐसे होता क्यों है, why is it undergoing elimination rather than substitution in case of tertiary alkyl bromide यहाँ पे, it is because students, bromine being a good leaving group, instead of a transition state जैसे SN2 में होता है, this first gets converted into a stable tertiary carbocation. We're not going into the entire elimination mechanism, but एक छोटा सा step बता दिया है that the alkyl halide, ठीक है, leaving group हम बोल सकते हैं, this is the leaving group, and we get step 1 में अगर elimination method में याद है तो formation of carbocation, and then eventually the base will extract a proton, and from over there you get your isobutylene. So you have to remember this condition. Okay students, so this was the first method, ammonolysis. Let's go ahead with the second method, which is probably one of the most important reactions. We have Gabriel Phthalimide synthesis. Gabriel Phthalimide synthesis. Now students, Gabriel Phthalimide synthesis starts from phthalimide. अगर हम NCERT देखें, so they directly start from phthalimide. But we're not going to directly start from phthalimide. थोड़ा सा हम carboxylic acid से Phthalimide पहले हम बनाएंगे and then phthalimide से we'll go and write the entire reaction. So we are writing the reaction a bit in a longer way but more in depth. So let's understand this. We start from, students, we start from phthalic acid. Students, ये है आपका phthalic acid. Now acid base reaction करते हैं यहाँ पे. So phthalic acid plus NH3. Students who have studied carboxylic acid, उन्होंने ये reaction वहाँ पे किया होगा. So what you get, acid, ammonia base है, you get an acid base reaction. तो सबसे पहले हमें मिलेगा salt. ये आपका अब बोल सकते हैं अमोनियम सॉल्ट मिला है. अमोनियम सॉल्ट ऑफ phthalic acid. हमें पता है स्टूडेंट्स एसिड बेस रिएक्शन, सो यू शुड गेट सॉल्ट एंड वाटर. द मोमेंट यू हीट दिस, व्हाट यू गेट हियर इज phthalimide. plus H2O. Exact mechanism नहीं करेंगे, just writing the reaction not according to the exact mechanism. Students, अब बोल सकते हैं यहाँ से O निकाल दो, यहाँ से H2 निकाल दो, तो आपको मिल गया आपका अमाइड. We will call this as phthalimide. Now students, ये phthalimide को if I repeat, ये phthalimide को if I further heat the phthalimide, ये देखिए students, I have written the same phthalimide. If I further heat this, so आप इसको बाहर निकालिए. ये आपने NH3 बाहर निकाला on further heating this. What we get here is phthalimide. Students, ये मिल गया आपको आपका phthalimide. So the reaction in the NCERT starts from phthalimide. But phthalimide कहाँ से मिला? This can be connected as a roadmap reaction to the chapter carboxylic acid, phthalic acid से. So phthalic acid से ये method हम जा सकते हैं till the preparation of phthalimide. Now यहाँ पे phthalimide with aqueous KOH or NaOH, what we get here is N potassium salt of, you can say, phthalimide, N minus K plus. And then here is reaction. ये सबसे important step है. Now you treat it with alkyl halide. Now students, this alkyl halide, ठीक है, we can take only primary alkyl halide because the reaction mechanism here followed is SN2. And यहाँ पे हमें क्या मिलता है? K goes away with ये K with X आप निकाल दो, so आपको मिल गया KX, and K की जगह पे now comes the alkyl group. Now students, the reaction doesn't stop here. इसके बाद the second most important part of the reaction, जहां से आपको आपका primary amine बनाना है. So this N-alkyl phthalimide, ये जो आपका N-alkyl phthalimide है students, now this, इसका हम करते हैं hydrolysis. थोड़ा सा एक अलग वे में लिख रहा हूँ इसको समझने के लिए. I repeat, what we're going to do is we're going to perform hydrolysis. So ये है with aqueous NaOH. Now students, NaOH का H मैंने यहाँ लिखा है and ONA I'm writing it here. Similarly, I'm writing H over here and ONA. This is just to explain it to you. Now observe this, RNH2. Plus sodium salt of phthalic acid. Sodium phthalate. Just like a potassium salt, potassium phthalate, sodium. ये Phthalimide का salt था, ये phthalic acid का salt है. Now students, the best thing about the reaction is इसका हम अगर फिर से hydrolysis करेंगे, we go back to phthalic acid. So we can reproduce phthalic acid in the end of the reaction. And what we get here is only primary aliphatic amines. Primary aromatic amine, for example, aniline cannot be prepared by this method. It is simple because aryl halides do not undergo nucleophilic substitution reaction. And if you want aryl halides to undergo nucleophilic substitution reaction, then you should have a electron withdrawing group at the ortho para position or ortho or para position. So let's write some more points over here. For Gabriel phthalimide synthesis, only primary aliphatic amines can be prepared by this method. I repeat, only primary aliphatic amines can be prepared by this method. Aniline, or you can say that primary aromatic amines cannot be prepared since aryl halides do not undergo nucleophilic substitution reaction. And JEE Advanced students, you remember another point in this, that yes, if you want to prepare aryl halide by this method, then an electron withdrawing group should be present at the ortho or para positions of the aryl halide. To prepare primary aromatic amines. I repeat students. So if you want to prepare primary aromatic amines, हमारा जो aryl halide हम use करेंगे over here, instead of the primary alkyl halide, primary aryl halide होगा, but वहाँ पे ortho para position पे you need a electron withdrawing group. For example, जैसे यहाँ पे अगर ब्रोमो लगा दिया तो electron withdrawing group at the ortho para position. And JEE students, another important point that the JEE Advanced JEE students, ये point JEE Mains में भी आ सकता है, and नीट में भी ये पॉइंट आ सकता है, ये अमाइन भी हम नहीं प्रिपेयर कर सकते स्टूडेंट्स। इसे हम बोलते हैं नियोपेंटाइल अमाइन। So even neopentyl amine cannot be prepared by Gabriel phthalimide synthesis. पूरा नहीं लिख रहा, I'm just writing that neopentyl amine also cannot be prepared by Gabriel phthalimide synthesis. I want students to put the answer in comments. Why do you think we cannot prepare neopentyl amine? और इसको और ट्विस्ट करता हूँ, can neopentyl halides undergo nucleophilic substitution reactions, and if they can, why? If they cannot, जो हमको दिख रहा है यहाँ पे, why can't they? So very important reaction students, Gabriel phthalimide synthesis. But since people, ये एक expert class session है, हम सिर्फ basic reaction करके नहीं छोड़ेंगे. We need to, let's say कि ये अगर हम एक road map reaction बनाते हैं, तो we can start the reaction cyanides से, and इसका जब हम डबल हाइड्रोलिसिस करते हैं तो हमें मिलता है थैलअमाइड। एंड देन थैलमाइड को आप थैलिमाइड में कन्वर्ट करके यू कैन कंटिन्यू विद Gabriel phthalimide synthesis. Similarly, we can also start the reaction from orthoxylene. And ये इसका students side chain alkyl oxidation, side chain oxidation जो अपने carboxylic acids में किया है in using alkaline KMNO4, हमें मिलता है थैलिक एसिड। एंड ये थैलिक एसिड को आप स्टार्टिंग पॉइंट जो हमने पिछले से किया था, देन थैलिक एसिड टू थैलेमाइड टू थैलिमाइड एंड पूरा प्रोसेस। सो स्टूडेंट्स, रिएक्शन का थोड़ा प्रीक्वल भी हम बना सकते हैं और इसे काफ़ी अच्छा एक रोड मैप रिएक्शन कंटेनिंग multiple steps we can do this. So please make sure you add this to your notes. Now let's continue with preparations. The next preparation is by method of reduction. अब यहाँ पे स्टूडेंट्स हम 4 different functional groups का reduction करेंगे and we will prepare amines. The first functional group that we're going to reduce, students, is nitroalkanes or nitroarenes. So what are nitroarenes? So we have, students, let's say nitrobenzene, and इसका अगर हम रिडक्शन करते हैं यूजिंग कैटालिटिक रिडक्शन यूजिंग निकल, पैलेडियम और प्लैटिनम, या स्टूडेंट्स एक बेटर रिड्यूसिंग एजेंट यहाँ पे जो हम यूज कर सकते हैं, विच इज tin scraps plus HCl or iron scraps plus HCl. Now the benefit of using this is, students, we get FeCl2 जब ये reaction होता है and hydrogen which is required for the catalytic reduction, that FeCl2 can be further hydrolyzed और आपको HCl मिलता है. So even a small amount of HCl can help in the reduction process. काफ़ी अच्छे से NCERT में भी explain किया है ये, so please make sure you remember that. And students, what we get here is your amine, aniline, plus we get H2. So the first reduction is, people, nitrobenzene or nitroarenes to aniline. This is the first reduction. Now the second functional group that we are going to reduce, students, second functional group is nitriles or cyanides. So students, यहाँ पे we have, you can call this as alkyl cyanide, you can call them as alkane nitrile, I leave it up to you. And इसका हम students कर रहे हैं reduction using set of reducing agents. मैं reducing agents students एक साथ लिख दूंगा आपके लिए for the next set of reduction. reducing agents एक साथ लिख देंगे. यहाँ पे 2H2 लिखा है, not the exact mechanism, मैं just simplify कर रहा हूँ. 2H यहाँ डाल दो, 2H यहाँ डाल दो, we get RCH2NH2. This is called as primary amine. इसे हम Mendes reaction भी बोलते हैं students, when a very specific reducing agent which is sodium amalgam and ethanol is used for the reduction, तो हम उसे बोलते हैं Mendes reduction. चलो, so cyanides on reduction will produce primary amine. मैंने कहा मैं reducing agents एक साथ दे दूंगा, तो चलो पहले I'll write the reducing agents students that we can use here. So the first reducing agent यहाँ पे students that we can use is same. We can have catalytic reduction using nickel, palladium and platinum. हम use कर सकते हैं sodium amalgam and ethanol. We can also use lithium aluminium hydride. So these are the reducing agents that we can use for the next 3 reductions that we're going to do, people. Students, ये मैंने set of reducing agents लिख दिया है. You can use these to perform. So nitriles or cyanides will produce primary amines. If I use isocyanide, students, cyanides and isocyanides are functional group isomers of each other. Now, if I have isocyanide and if I perform the reduction of isocyanide, very important students, डब्बा मैकेनिज्म से ही करेंगे इसको. एक H यहाँ डाल दो, 3H यहाँ डाल दो, you get R NHCH3, we get secondary amine. So primary amines on reduction, cyanides or alkane nitriles on reduction will produce primary amines, but isocyanides or carbylamines on reduction will produce secondary amines. And the last that we have, student, is amide. Amide is R C double bond O NH2. Again amide with, let's say, lithium aluminium hydride. इसका अगर हम रिडक्शन करेंगे, अगेन स्टूडेंट्स डब्बा मैकेनिज्म से कर रहा हूँ, 2H2, ये H2 और O चला गया, and you get H2O, and this will give me RCH2NH2, which is primary amine. But students, depending upon the amide that we use, आप secondary amine and tertiary amine भी बना सकते हैं. For example, if my amide is like this, N-alkyl alkanamide, then students, when you perform the reduction of N-alkyl alkanamide, This will give us second degree amine. So यहाँ पे same students, एक H2 is here and one H2 attached here. This is N alkyl alkenamide. यहाँ आपका है N alkyl alkenamide, that gives a secondary amine. And students, if I use N comma N dialkyl alkenamide, ये इसकी रिडक्शन अगर कर दी स्टूडेंट्स, then this will produce for me a tertiary amine. So amides, depending upon students whether you use a primary amide or whether you use a secondary amide or whether you use a tertiary amide, that on reduction is going to produce primary amine, secondary amine or tertiary amine. So these are the different reduction techniques that we have. Now let's move towards the last preparation technique, students, and the most important, one of the most important, this is called as Hofmann's bromamide degradation. Hofmann's bromamide degradation. Chalo. Now let's first understand the reaction Hofmann's bromamide degradation. And students, for JEE Advanced, I will also give you the mechanism of the reaction. Very, very important. Some very minute details in the mechanism you'll understand. So हम यहाँ पे start करते हैं students with a amide. So हमारे पास है RNH2, bromamide, so bromine and KOH, aqueous KOH. Mechanism में हम समझेंगे कि हम base का काम क्या है. Students, the same Br2 and KOH, you can write it as KOBr, potassium hypobromite. So the reaction you can also write it as R C double bond O NH2 and NaOBr या KOBr भी चलेगा. Both mean the same. Now what happens here is, students, you get a amine containing one less carbon than the parent amide. तो parent amide में अगर 2 carbon थे, then in your primary amine you'll have 1 carbon less. And यहाँ पे students, you can get both. You can get primary aliphatic amine or you can get primary aromatic amine. Doesn't matter. And इसके साथ students हमें मिलता है NaBr, pardon me, I'm using sodium, so KBr. Then we have carbonate K2CO3 and H2O. तो जल्दी में बैलेंस अगर हम कर दें तो I think 2 Br है, so 2 over here, it is a 4, so 4 and 4 hydrogens over there. I think 2 over here, that should balance the reaction. Yes. Now students, थोड़ा सा इसे और in depth जाते हैं. Now in Hofmann's bromamide degradation, in HBD, students, what's happening here is, please understand this carefully. This has been explicitly mentioned NCERT में. mechanism में तो और detail में study करेंगे. Alkyl group transfer takes place. I repeat, okay, there is an alkyl group transfer. From the alkyl group which was attached to the carbonyl carbon टू द नाइट्रोजन. ठीक है, ये एक अल्काइल ग्रुप ट्रांसफर होता है इस रिएक्शन में, एंड वी नीड टू नो दैट. एंड आई रिपीट स्टूडेंट्स, let's say if I do this reaction for benzamide, ठीक है, यहाँ आपका benzamide है, we are doing Hofmann's bromamide degradation. The product that I will get here is containing one carbon less. So हमें मिलेगा students यहाँ पे aniline. So benzamide to what we got here students is aniline plus ये जो बाकी के products थे, we get those as well. Now this is Hofmann's bromamide degradation, but JEE Advanced students, let's understand. Mains and NEET के लिए this should be sufficient enough, but for JEE Advanced we need to go into the mechanism in depth. So students, let's understand students the mechanism of the reaction, the mechanism of Hofmann's bromamide degradation. Okay, shortcut में लिख रहा हूँ HBD, Hofmann's bromamide degradation. Let's understand students what happens in HBD. So we start with students, this is your amide and KOH में वो जो OH था आपका बेस एक्सट्रैक्ट करता है प्रोटॉन. सो दिस एक्सट्रैक्ट्स प्रोटॉन, एंड जैसे हमने प्रोटॉन एक्सट्रैक्ट किया, सो वी हैव R C डबल बॉन्ड O N H. अब हमारे पास नाइट्रोजन पे आ गया है नेगेटिव चार्ज 2 लोन पेयर से, and this nitrogen will now attack. So ये आपका Br2 है, यहाँ से हमने ये Br ऐसे एक्सट्रैक्ट कर लिया. So we have R C double bond O NH and Br N bromo alkanamide. Now what happens in the next step is अब ये N bromo alkanamide फिर से your OH minus, यहाँ पे आपका OH minus will again extract, एक लोन पेयर है यहाँ पे, OH minus फिर से करता है प्रोटॉन एक्सट्रैक्शन. सो हमें मिला R C डबल बॉन्ड O N, आगे नाइट्रोजन पे नेगेटिव चार्ज है यहाँ पर, एंड Br. Now students, यहाँ पे this is where the magic happens. So be careful and see what happens in the next step. Multiple changes मैं एक साथ लिख रहा हूँ. So these lone pairs आप यहाँ पे shift कर दो. I can see that is a step number 1. Lone pair ये electrons on oxygen, and आपका bromine is the leaving group. So एकदम सीक्वेंस पे जाएं, so this should happen something like this. ये आपका लीविंग ग्रुप, लोन पेयर यहाँ पे आ गया है, एंड इलेक्ट्रॉन्स. This is not exactly the chronology in which it will take place, but इतना हमें याद रखने के लिए it is more than enough. So what we have here students is R. और एक और चीज यहाँ पे बहुत इंपॉर्टेंट होती है, ये जो आपका अल्काइल ग्रुप है ये मूव होके जॉइन हो जाता है टू नाइट्रोजन. मैंने कहा था जो अल्काइल ट्रांसफर होता है, दैट ट्रांसफर इज टेकिंग प्लेस ओवर हियर. हमें क्या मिल रहा है यहाँ पे, C O माइनस CO माइनस. अल्काइल ग्रुप तो अब इस नाइट्रोजन पे, नाइट्रोजन इज डबली बॉन्डेड टू कार्बन and these electrons will come back here. ये मिल गया आपको आपका अल्काइल आइसोसाइनेट और यहाँ पे स्टूडेंट्स हुआ वो अल्काइल ट्रांसफर. This is where the alkyl transfer takes place. Mechanism थोड़ी सी complicated है, but let's focus and let's try to do this. Now, ये आपका alkyl isocyanate हमारा जो OH माइनस है, ड्यूरिंग रेजोनेंस दीज इलेक्ट्रॉन्स, ये कार्बन पे जो हमने ऑक्सीजन पे जो हमने बनाई थी ओवर हियर, ये कार्बन पे प्लस चार्ज था एंड दिस OH माइनस अब ये कार्बन पे जाके अटैच हो जाता है. सो यू हैव O माइनस C OH double bond N and R. Now students, what happens here is intramolecular proton transfer. Now let's try and understand students the intramolecular proton transfer over here. ये डबल बॉन्ड ये यहाँ पे आप ले लो, ये H is in the form of H plus और वो आ जाएगा यहाँ पे. So we have O double bond C O minus and N H and R. ये हो गया आपका इंट्रामोलिकुलर प्रोटॉन ट्रांसफर. एंड देन स्टूडेंट्स व्हाट हैपेंस इज ये जो इलेक्ट्रॉन्स हैं ये ब्रेक होके आप नाइट्रोजन पे ले लो. सो यू हैव O double bond C O minus सिंगल डबल बॉन्ड बराबर था कहीं पर. हाँ स्टूडेंट्स, यहाँ पे एक छोटा सा चेंज करना है. यहाँ तक it remains the same. Okay, one step over here before we do the intramolecular proton transfer. During resonance आप इसको यहाँ पे ले लो. So we have, और ये आप इलेक्ट्रॉन्स यहाँ पे ले सकते हो. So O double bond C bond OH N and R. Now we perform the intramolecular proton transfer. So we have O double bond C, ये O minus N H and R. Pardon me, थोड़ा सा मिस्टेक कर दिया था यहाँ पर. This is how the intramolecular proton transfer takes place. The alkyl isocyanide OH आके इस कार्बन पे अटैच हुआ. These electrons will move here, double bond. These electrons shift onto nitrogen. Nitrogen पे आ गया negative charge. The IMPT intramolecular proton transfer. And next step में these electrons will come here और ये निकल जाएगा. So when these electrons come here, C double bond O, C double bond O is CO2 plus NHR. Again nitrogen पे there is a negative charge. And finally, solvent से nitrogen will extract a proton. ये आपका catalyst फिर आ गया, and you get your primary amine. Okay, so थोड़ा सा बड़ा mechanism है. This is, students, JEE Advanced especially, this is how the entire reaction takes place. एक बार आप ध्यान से देख लीजिए. Now, एक दो पॉइंट अगर हम याद रखें यहाँ पर, few points, JEE Advanced students, that ये जो alkyl isocyanide वाला जो step हुआ था आपका, that is a very 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 important step. Then even for mains and NEET हम एक point याद रख सकते हैं people, that electron donating groups increase the reactivity. ठीक है. In Hofmann's bromamide degradation reaction, people, the presence of electron donating groups on amides increase reactivity towards Hofmann's bromamide degradation. This is a very important point, students, that you should remember. This was the mechanism. I hope if there was any doubts or any questions in the mechanism, please leave your comments behind. Now students, this was part 1 of the expert class. In the second part of the expert class, what we will do is we will do all the important reactions of amines. Along with that, we'll do a very very important topic जो GOC के लिए भी very important है students. इसलिए वो lecture थोड़ा बड़ा भी होगा, which is basicity of amines. हम पूरा basicity को करेंगे in detail. We'll take lot of questions. So thank you students. I will see you all in the second lecture of amines. Please share, subscribe, like, and share it with all your friends who are preparing for entrance exams. Thank you students. Thank you so much.